Okay, so our final example is going to show you how I could make the question a little bit more challenging, other than just taking one and plugging it into the other. The strategy is still the same. We're going to take one and plug it into the other, except you'll notice that the line here is in parametric, so that's good news, so we don't have to rearrange it. But unfortunately, the plane isn't in scalar. So before we go off and do anything, we're going to have to put this in scalar form. So coming up with the direction vectors first, D1 will be looking at the coefficients on K, so it'll be 1, 3, 0. D2 will be the coefficients on L, which would be 0, -5, 1. And I need a point. Luckily, I don't need to guess here. The point's right here. It's the constant, so it's 2, 0, 0. That's all the information I need to get the equation in scalar. We're going to have to cross multiply. Or not cross multiply, excuse me, do the cross product. So off to the side here, let's do the cross product on these two. So I'll give you a second if you haven't to do the cross product. Double check stuff, but I'm pretty confident that that's my answer. So that means that's the normal. So normal is 3, -1, -5. Which means I have almost my whole answer, 3x minus y minus 5z plus d equals 0. Next then I'm going to take my p value, plug it in to get my d value. So the 2 and the 0 and the 0 plus d equals 0. So obviously that means d equals -6. And therefore, we've got the scalar equation. So a little bit more work. It would have been nice if we had the scalar equation at the beginning, because then we could just substitute it in. But this is where it's a nice question, actually, because it does get you to do a little bit of what we did yesterday and what we're doing today. And so now we're going to investigate the intersection. Luckily, this is in parametric, so we're just going to sub it in. So wherever we see an x, we're going to replace with 2 plus 3t. A y will replace with -3 minus t. And the z we're going to replace with 1 plus 2t. -6 equals 0. Give myself some room. Rainbow, 6 plus 9t plus 3 plus t -5 minus 10t, and then -6 equals 0. Click my like terms. 9 plus 1 is 10, minus 10, 0t. And then I get a 6, and 9 minus 5 is 4. -2 equals 0. So 0t equals 2. That, as we like to say, is absurd. It's impossible. There's no value for t that you can multiply by 0 to get 2. So, since this is absurd, that means that when I check the substitution, when I plug the one into the other to find the point of intersection, there isn't one. So therefore, there is no intersection. So it must have been that this line was parallel and distinct from the plane. Could we have predicted that at the beginning? I don't know. Let's look at the direction vector. Look at the direction vector of the line. You know, the direction vector of the line was 3, -1, 2. Is that similar to any of the direction vectors on the in the equation of the plane? No. But remember, there's tons of direction vectors that describe the plane. There's an infinite amount of them. Just imagine all the different direction vectors I can draw on that tabletop, right? I can have one here and here and here and here and all over the place. And so it's too hard to nail down if you would have known that these are parallel at the beginning. Just go off, do the substitution. Um, when you do the substitution, you get three possibilities. You'll get t equals an actual number, and you'll be great, and you get a point. You'll get 0t equals 0, which means everything could work. Or you'll get 0t equals a number, which is absurd, and you'll have no intersection. So these are good questions because it does get you to do a bit of practice from stuff from yesterday. And the other way, here's the homework is on page 218, number 3, 5, 6, 7, and 8. By the way, the textbook again likes to show various different ways. Look at this, what you have here, 4, 1, -5, dot xyz equals 0. It's another way to write it in scalar form because if you actually did this dot product here, what do? You multiply the x's together for the 4 times the x, the y's, the 1 times the y, the z's, and you add them together. So, I mean, it's exactly the same. It's just they're trying to make things a little more complicated. Okay. Good luck.